Okay, I want to go over some of the things that we needed to do to set up and do the thermocouple lab. The basic premise of the lab was to be very similar to the RTD lab, which we did last week. There was a couple of additions. So the first thing we needed to do was to get 2 thermocouples. Now, some of them have markings on them for blue and red, and as you go through the lab, you'll be using each of these 2 different times. So in this particular case, these ones are marked. If you just, as long as you had one that was marked and identified from the other, that was sufficient. You also needed to have a RTD, so that the RTD itself could be used as a comparison as you're doing your measurements. And there was some other requirements like tape. There's also mention of having 2 multimeters, simply because if you're working in pairs, for example, it's easier to do all the measurements at the same time without jumping around. You're going to be using both the RTD transmitter and the thermocouple transmitter, and these both have to be powered up. They don't work on osmosis. They have to be powered up to be amplified. So the red and the black came from the power supply on the back side or on the Bryant brush box from the front, and then we just simply use the same size cable, and these can stack on the back, and they go positive and negative, just like that, so that this is now, these are now connected, and we can take the wires, kind of move them out of the way so they're not tripping on stuff, and that's now powered up, that's powered up. Then you had to check the settings on them to make sure these switches are in the RTD 0 to 100, and this in the thermocouple 0 to 100. Now there are 4 different thermocouple transmitters. One of them was kind of suspect as we walk around watching the transmitter. If the numbers don't start making sense, don't be afraid to move over to another one and try it, and let me know. Say if this one is not working, let me know, and then we can get it out to be serviced. Okay, that's the basic premise. Just to get the setup, you are going to need the cold water eventually, but at this point, for the first initial setup, we should be in good stead. All right, so the next questions that were asked basically was focusing on the information you need to proceed with the lab. So one of the questions was, what is the range that we're working with? Now we set all these switches up to be 0 to 100 degrees. So 0 to 100 degrees is our range, and from that we're looking for temperature. So our process variable is the temperature, and the range is being followed through by the 0 to 100 volts. If it's range, it has an R process variable. R is in process, so you can tie those 2 together to get that clear. The signal itself, we're going to be looking at a 0 to 5 volt signal in each of these. So when this is fired up and we have the devices connected, an output relative to the device detection is going to be transmitted out of the output. So we need to put our meter at these 5 volt locations. So it's the easiest thing to do is, before you go anywhere further, you just basically hook the negative lead to the negative, and once we get the RTD hooked up, then our 5 volts will be ready. When we need to do the measurement, we simply take the lead out and put that on the negative side of our thermocouple on the bottom. So let's get the thermocouples ready to go and take it from there. There was a part that talked about taping down one of the leads of the thermocouple. Now the idea here was that we can then take measurements directly off of the thermocouple to see what the millivolt signal is being generated from the raw signal. We've already discussed that this, as a method of getting an accurate measurement, is not ideal, because taking the 2 leads from the multimeter is actually introducing a new junction, which is creating basically another thermocouple, which will oppose the first one. So it's to get an idea of what the raw signal is and be able to compare that to the signal we're getting at the transmitter. So we now have our meter set up, and it's reading right now AC volts. I want to go to DC volts, and I'm going to put it to the lowest setting without it going. This is not an auto ranging one, so I'm going to put it to 4. And I'm going to use the 2 leads to check against the actual thermocouple itself. Put that down, and we'll see what kind of reading we get. Now these are polarity driven, so if I put this one way, move it off to the side, DC, and right now it does not appear to be giving me any voltage. So let's change the other side just to make sure I haven't got it reversed. And it's not unusual to find that you get no answer, because the thermocouple is at the same temperature as the leads. So if there's a voltage, it'll be very minor, because there's no difference in temperature to start the Seebeck effect. If I hold this is going to be kind of tricky, but I'll do my best, and I were to put the 2 leads, the thermocouple should start to warm up if it's not broken. .5 millivolts. Okay, let's leave it in fresh air. So right now it's reading about 0.4 millivolts and dropping, because there's only a slight amount of energy between the difference between here and the deck here. So all of the measurements that we'll be doing, the idea is to be using this and moving the thermocouple itself on one part of our equation, so we can actually look at what the raw data is versus what's going on once it's in the transmitter. So now what we're going to do is I'm going to plug in the RTD into the RTD transmitter. This is exactly the same as we did during the RTD lab. We have 3 connections, 2 black and a red, so they simply go in 2 black and into the red. We've already done the calculations in the past with respect to the leads, so we know that one's going to be canceled out, or reduced, shall we say. And the other, we have our RTD lead we're going to leave on the deck, and it's going to be the ambient temperature sensor for us. Now we just need to do is to find the amount of voltage that's being put out. So right now, our outputs over here, we're going to be using the 0 to 5. And because it's a voltage, because it's a signal, that means that's our span. So we're going to take our black lead, put it into the power, because we need to have the same reference as this 0 volts. I'm going to take the red and put it into here. And we're going to change our setting, because we've got 0 to 5. And our thermocouple, we're on DC volts. That's in the correct one, that's in the correct one. And got to turn the power on, that would help. And we can see right away that it's generating a voltage for us just in the fresh air. I can move this around to get it to drop a bit. And it's putting out about 1.34, say 1.35 volts. So that would be the ambient temperature based on the resistance that it's detecting through the transmitter. Now we can do the same thing on the thermocouple side. So to do that, we're going to take these out. And on the thermocouple itself, you should have got one of the 2 thermocouples, picking one of the 4. I've got this one set up. I've already supplied 24 volts to it. So now I need to put my red lead to the 5 volt side. So I'm going to detect whatever voltage there is. And I'm going to take the other side, the black wire, and I'm going to put it to our mutual ground. And right now, it's putting out a voltage of 1.13. So that 1.13 is part of our signal, so it's part of that span of 0 to 5. That would be the one we'd be using to calculate. The millivolt rating that we've got when we measure just the lead itself, that's going to be compared to the table to see how far off there's a difference between measuring it improperly and amplifying the signal through a transmitter. Okay, so right now that's our our current signal being transmitted from our thermocouple transmitter to our meter. That would be the signal we would receive at the other end, and we would process to say what the temperature of the actual temperature of the process is. All right, so we're going to do our cold measurements now, and we've got the ice water here, well, block of ice, and we have the two thermocouples in the same tub, and we've also got the RTD. So all of them are being cooled to the temperature. So the transmitters will still be doing a 0 to 5 volt signal, but we're going to now I've moved these two leads so I can check them directly. I'm going to do that last. I'm going to do my 2 voltage readings and see what the transmitter is doing, and then we're going to take a look at what's happening right at the tip of the thermocouple. So right now, I'm not getting any voltage because I have not plugged in the leads. So I'm going to start with my RTD. Again, I put the black on the negative side here. And I'm going to put the red on the 0 to 5 volts. My RTD is pushed in. I'm still at my 5 volt range. And if I go up to 40 just to make sure I'm not losing anything, it says I've got 0.11 of a volt. So that's really low. But we're expecting low because it's cold. Okay, so we've got 0.12 volts. That's a good indication. So we're going to take this out now, and we're going to see what our friend the thermocouple is doing. And the same thing applies. I put in my red first if I want, and then my black in the bottom, like so. So now I've got those two connected, and we look at our meter, and it's giving even a lower signal. So our thermocouple is right in the ice. It's touching the ice. So it's a very, very small signal. So right now that's 20 millivolts. So we've got our power still on. We left that all on. That's all good. That's in the right spot. We're on the right transmitter. So that seems to be the voltage we're getting for that, which is about 20 millivolts. All right. So now we're going to move everything over, and I'm going to change it to resistance, and I'm going to measure the actual millivolts. I'm going to measure the millivolts being created because there's a difference in temperature between the air and the water. So I'm going to unplug my tester. Sneak around the back, and we're on millivolt. We're on volts still, but I'm going to drop that down so I can get a more accurate reading on this particular meter. And I'm going to take the 2 leads. And this is using that other thermocouple. The other thermocouple is exposed to the same temperatures. So now we're just looking right at the leads. And it's showing pretty much less than 20 millivolts. 2 millivolts. Very small signal. Okay, now we've done the cold part. We've done the atmospheric one. We've done the cold temperature. Now it's time to heat things up. All right, so I've still got this hooked up to my meter. Now I've got to put on the RTD. We'll do the RTD first. And right now it's quite frosty. So I'm going to heat that up and see what happens to the temperature. And this is a nice thing about it. You have a portable heat source. So I'm going to warm that up. And you can see right away it's responding. It's already got up to half a volt, 3/4 of a volt. And this will take some time because I can still feel it's cold. So this will take a few seconds. 1.25 and climbing. So at a certain point it's going to level off. That's the voltage we would use, and would use the process variable is equal to the signal minus the offset divided by the span times the range plus the lower range value formula to figure out what the actual temperature is, because the process variable is temperature. So we're up to 1.5 volts, 1.4. It's like a clock up timer. Any time now. So we're at 1.5 volts. And it will keep climbing because of the temperature going to increase. As soon as I let that go, it's going to start adapting to the ambient air and it's going to start to drop. So when you do this part, you just make sure that you've got it warmed up and you wait till it stabilizes. I'm not sure where this is going to end, so I'm going to move on to the next one because time is not our friend. Okay, so now we're going to do the exact same thing, but now we're going to move this off of the RTD transmitter onto the thermocouple transmitter. Now, you're working in pairs, and in the lab, I checked, it does say use 2 digital multimeters, because if you're working in pairs, and you both have meters, 1 meter, the other meter, that's half the effort, half the time, twice the efficiency. Okay, I'm going to move this down to our thermocouple one, and I'm going to put that in the 5 volts. I've still got my thermocouple plugged in. Careful not to remove that. Oops. Put that back. Put that in my negative. Okay, that's all good, that's all good. Still got that. And right now the thermocouple is in the cold. So I'm going to bring it out of the cold. And we can see that we're still connected up to the thermocouple. It's all wired up. So now we're going to start warming that up. We're on volts. And I didn't turn off the power. That's connected to the 5 volts there. And it says 0. Power is still on. So if we have a suspect here, I'm going to change this over to this one to see if that makes a difference, because we should be reading something. I haven't got a hold on this. That's plugged in. This is the right thermocouple. That's not quite right in the state of Denmark. Oh, that would make sense. When I pulled this out, I pulled the connection lead to the thermocouple, so I didn't have a complete circuit. Troubleshooting. Professors. Gotta hate them. Okay, we'll put that back in. Now let's check my circuit. I've got that going to there. Good, I got that going to there. So I can push this back in here. And whoop, boom, chakalaka, I'm getting a voltage reading. So I'm going to warm that up. And we can see that the voltage is climbing quite quickly. And it's going to get to a point of stabilization. So these devices are taking that millivolt signal and amplifying it. It's sending out a small voltage, and it's going through the resistance and measuring what's coming back and then transmitting it. You can't get an accurate reading just by, well, not osmosis. And if you want to do a lot of math and stand beside a machine and go, okay, I've got the RTD, I'll do the math, or you can wire up a transmitter. So it's already up to 1.76 volts, so 1,000 millivolts. So that is this is where we get a little confused, because a thermocouple generates a millivolt signal. We're thinking that this is actually going to go to the table. It does not go to the table. This goes to the transmitter below, and that does all the math for us. Now, that brings the question up, well, where is the millivolt? Why didn't we see the millivolt? And that's a very good question. It's because I haven't measured it yet. Okay, so now I'm satisfied I've got a reading for that. I'm going to put this back down to my minimum setting again. And it's going to complain because it's getting something way more than it's designed for. Okay, I got it. You're complaining. I still have my lead here. Now this is where it's going to get a little tricky, because I have to pull this out and I have to put it somewhere warm like my armpit, and I've got to measure its output. And of course we're all tangled up because that's what you do when you're not paying attention. When you go to use your meter, you can see that the wires are already twisted. It's a good habit to get into from the first day that keep the red lead in your right hand. You be positive that it's in your right hand and your left hand. And if you do that, you'll find you won't be tangling it. Nobody ever taught me that trick. This was like years ago, and I'm always mixing them up. All right, so I've got these two. I've got that set here. So now I'm going to push that down again. I've got the positive and negative on either side of that, holding it tight. And I'm getting about 1 point, oh, it's jumping around. So that says 4 millivolts. So that's a stable signal. I'm not grounding anything out. I'm trying to squeeze it with my armpit as high as I can. So that would be the actual signal that is coming from the thermocouple. Now keep in mind that that's not a true signal. It's a guide, because the second we touch these, with these, we create a counter voltage, which reduces the actual real voltage that's being sent by the thermocouple. And that's where we use the reference, the measuring, and the 3 different voltages to determine how much we're actually losing from this. And that's pretty much the whole lab. Now, the thing is with labs or any instructions that you're given for the first time, you've got to take the time and spend a few minutes reading and asking questions before you jump in. Fools always rush in, and the fools get hurt. And if you're not sure of the equipment you're using with, if a person said, "You'll just grab out and change out the fuses," well, you immediately want to do it as fast as possible to prove your worth. But is the power turned off? Do you have replacement fuses? Do you have a fuse puller? Do you have the proper gloves? These are things that you've got to stop and think about, because if you don't, you can end up being in a situation where it'll be the last fuse you'll ever pull out. So everything here is safe, and we're trying to keep it that way. But anyway, you can now see the process of the lab. I've gone through and reviewed the steps, and if you did it exactly as it said and didn't skip steps, it would have been just about as easy as this. Well, it would take a little longer kind of figuring out. But I was actually quite surprised that you forgot how this was wired, to be honest. But anyway, okay, so when we come back next week, we're going to do the same thing again. We'll set this all up. And if I get in early enough, I'll make your life a little easier, because time is not our friend anymore. Since the beginning of the semester, it hasn't been a friend. I will try to have these set up ready to go. So you just basically go and take the measurements, take the recordings. If your recordings are the same as before, then great. Just finish the math and send it, submit it. Some of these readings, I don't know whether they'd be accurate enough for you to trust to insert on your lab, but at least you have an idea of the process and what we were attempting to achieve.